Activity is the most basic component in Android SDK. Almost every application has at least one activity, though it's not a requirement. It's responsible for communication with the user, capturing his actions, such as clicking a button, and performing basic logic associated with views. Activity would be a controller for us if we wanted to use the MVC pattern for Android applications. MVC, Model View Controller, is probably familiar to you if you have written web applications in, for example, Ruby on Rails, or in Java frameworks, which also often implement this pattern. Very often, in books, tutorials, and even on the developer's Google.com website, we can find examples which present activity as a very long class, which usually consists of many other internal classes. Because of this, the biggest activities can have several thousand lines of code. However, this means that they are completely unreadable. Our goal and the purpose of this training will also be to show examples of how to make activity just transfer signals from the user to further business logic of our application, and be responsible only for controlling the view. A very important thing, which is almost forced by Android SDK, is that an activity should be an entity separate from other activities. In fact, in a standard Java application, we have a method called public static void main. It takes a list of strings as arguments. Since in Android we write in the Dalvik platform, not JVM, this method is not required. Dalvik expects a slightly different structure. Theoretically, each activity of our application can be started from other places, not only our application as long as we know its contract. That is, we can start it if we know what arguments to pass to it, or which action to call. It's often used, for example, when we want to turn on a Twitter application from within our application in order to send a message on Twitter. It's a very large feature in the Android platform, thanks to which applications can easily communicate with each other and integrate. People often try to avoid the fact that activities should be independent from each other, and create their own applications, global values, and singletons, which have only one instance in the entire application. In fact, they store information that is later used by several activities and even modified by some of them. This causes a lot of problems later. We can't predict when the Dalvik garbage collector determines that there's currently very little free memory in our phone, and we have to free some of it. So we free the memory of a singleton which we relied on. Because of this, all of a sudden your application may stop working. This causes security problems if some data related to our permissions were stored here. Actually, we should not write a class that has a static method getInstance checking whether the field is empty. If it is, we allocate the memory for the object, and if not, the function returns something that has already been allocated. This leads to considerable problems and contradicts the concept of an activity. For the exchange of information between activities, we use intents. In fact, the intents are used in almost any Android application, even if we do not use them ourselves in our code. We also use them to communicate with such things as services or broadcast receiver. In fact, everything in Android which is a separate context uses the intents to connect with other contexts, for example, between two different activities, or between an activity and a service. We'll discuss this later. The intent is actually a container, and one of its functions is collecting various information, or values. Into a simple intent object, we can put primitive types, such as int, long, double, boolean, that is, objects which are wrappers for primitive objects. We know them as integer, long, or double. We can also put strings in there. The most interesting thing is that we can also put whole objects which implement the parselable interface, a solution specific for the Android platform, as well as the serializable interface, which is known to practically every Java developer. Why is our intent so limited? Why did the Android developers decide that they will not let us, for instance, put a reference to the type object, which does not implement any of the previously mentioned interfaces? Why did they put such restrictions on us? In fact, it's also related to the fact we mentioned a moment ago, that activity and contexts in the whole application are independent of each other. This means that by an intent, we can't pass, just like that, a reference created in one context to another context, so that the second context would be able to edit the value belonging to the first. Such communication is prohibited. All the data that we put into the intents are copied. They are actually serialized and a copy of them is created. Therefore, we must use serializable or parcelable if we want to put in there some more complicated objects. Thanks to this, we're sure that a child activity, or the one that is started from the parent activity, will not modify any state of the activity that called it. This way, we can be sure that our application will run reliably if we allow our activity to be started from other applications. Unless we rely on global values. As mentioned earlier, it's not an absolutely good solution. The code shown below is probably recognized by all Android developers who have written at least one application. This is the standard way to create an intent and start some activity, in this case, B class. In this code, we put something named extra. In this case, it's probably a long because that's the standard ID in Android used by lists, adapters, and content provider. However, it may also be a string if, for example, our web services use an SQL database. The third line on the slide shows that we put in there almost the whole model of some other order, M-order. Perhaps this M-order implements the serializable interface, or parcelable interface, so it can be easily copied and used in a separate activity. Finally, in order to start the activity, we use method startActivity. It's available in each activity, and indeed in any context. That's why we can start an activity from a service, and broadcast receiver, because there we also have access to the context. Since Android has released its SDK and developers began to write applications, a controversy continues whether to use parcelable or serializable. As the parcelable is the component specific for Android, it's the recommended solution, considered to be much faster than the serialization typical for Java. This is more fitting for Android, and according to the documentation, as well as speeches given by developers on, for instance, Google I/O, it helps to conserve battery power. This does not mean that using the serializable interface to pass more complex objects is more expensive. It is also not true that applications that use serializable and exchange information on the basis of the object do not work. I think every Android user has installed on his or her phone many applications that use these interfaces. If we use both interfaces in a rational way, surely there will be no problems. However, on older versions of Android, sometimes there may be errors due to the fact that the context is unable to handle our serialized class. These systems may not be able to read and map the byte stream passed through our intent to the appropriate class. So we get a runtime exception and the application stops working. But this is not a frequent case, and usually it is caused by some mistake of developers. For instance, failing to generate the serial version ID. How does the parcelable interface look? In my opinion, creation of this interface and its implementation in such a way that the objects could be exchanged between intents is far more complicated than it should be. Developers of Android and Android SDK could have done it a lot better. Unfortunately, ever since the version API Level 1, there's been implemented the solution shown in the slide, and we need to stick to it. In order to create the parcelable interface, we need a static field, the final creator. As you can see, it is cast in the type myParcelable. In case of earlier examples, it could be, for example, order. The interface shown implements two methods. We got an anonymous class here. CreateFromParcel, which receives parcel, is similar to a bundle. There's also a second method, which creates a whole array of objects based on an argument size. As you can see, it is not very difficult. However, all of the implementation and how parcelable should behave is hidden in the constructor called from the method CreateFromParcel. To the constructor, we pass the parameter parcel, and then we load the parameters from it. An exemplary constructor might look like on the slide. You may be surprised that the constructor is marked as private, but in fact, if you put static classes in one file, you'll be able to call private constructors, because the anonymous classes can access the private components of the classes surrounding them. Here we see that we load some integer from the parcel passed to the constructor. The second method, WriteToParcel, is also forced upon us by implementing of the parcelable interface. The order of writing our data to those parcels is very important here. In the same order in which we write data to parcels, in a WriteToParcel method in the parcelable interface, we later read the data in the parcel in. It is a very low-level solution, almost primitive. However, that's what makes it very fast. It's not based on reflection, and in fact, we can decide exactly which fields are to be serialized to the given parcel. The serializable interface, as you may have guessed, is much simpler. In here, we have a class mySerializable that implements it, as well as a field mData. Let's assume that somewhere in this class are some setters and getters. This is actually all we have to do. Of course, we can also generate serial version ID, which will allow the intent to identify, when reading data, what is the exact class that hides behind the implemented interface. All data in this class will be automatically written by the serialization mechanism. The serializable interface is very simple and does not require a lot of work. While the parseable interface is quite difficult to implement and having objects composed of other objects, it could prove to be quite tedious. This raises the question, and a temptation for all of us, whether we should use serializable in Android applications. The answer is absolutely not. Parseable and serializable can be used to store the state of activity at the moment of killing it, or actually stopping it. If our activity is removed because, for example, we change the orientation of our device, a new activity is created. But we have a chance to retain the old state of the activity, that is, before the orientation change to the new activity. We can write an application which, for instance, has some sort of list, and we want to retain the currently highlighted item on the list. That's what the method onSaveInstantState is for. And we need to override it in our activity. Into the bundle method, we could put ordinary things that we could put into an intent. In fact, intent is a wrapper for a bundle when data exchange happens. We could put in there information of a type ID key based on the primitive types of type long. Naturally, we can put serializable and parseable, and everything which we previously put into intents. A very important thing was said during the Google I/O conference in 2010 by Google developer Virgil Dabyanchi. The less data you parcel or serialize, the faster your application is. What's behind this? In fact, in most cases, we do not need to pass either serializable or parcelable to the context, and we should avoid it. Usually, it's enough to simply send an identifier of a given object to the intent, or pass a URI by intent. Then, the context called in this way will be able to get to the selected resource, for example, through the content resolver. This does not mean that creating parcelable or serializable and copying is particularly resource-consuming on a mobile phone, such as Samsung Galaxy S3, which has 4 cores. A good pattern is to pass as little information as possible, because aside from performance issues, this makes our code much easier to read. Saving of activity state, which was made in the onSaveInstantState, can be later read in onRestoreInstantState. There too we get the bundle, and it's exactly the same bundle which was saved in the previous method. Thanks to the data placed there, we can recover the state of an activity from before orientation changes, or before killing it. We also get this bundle as the SaveInstantState box in methods such as onCreate or an onPostCreate. But before we use it, we must remember to check if the field is not null. If our activity is booted for the first time, or the system decided that the activity has been used a long time ago and the user does not remember the previous state, so it should delete it and start with another default state, we need to check if the bundle is not null. If so, we must open the default state of the activity. In most cases, we save the state of the activity to a bundle object. Then, all the data is serialized, that is, actually copied. But it sometimes happens that an instance of the object that we want to save is quite large. We may also want to save it just because the time of allocation of an object is quite long and we do not want to do it again. For instance, when changing orientation. Most often, it's not about saving an item on a list or other basic things. It could be a thing like a large bitmap, the allocation of which takes a few seconds and there's absolutely no need to do it for a second time in the activity, which actually has simply changed orientation or has been resumed. This is done with the method onRetainnonConfigurationInstance. This method is regarded as a method that should not be used in applications. And it's hard to argue with that. We'll need it very rarely. In fact, the Android SDK allows us to return from this method to a reference to an object. It doesn't have to be a serialized or parceled object. It will then be passed to the child activity. That's the activity started after changing orientation, or booting again after some time. Android SDK uses this, for example, to keep a reference to the loader manager. Thanks to this, the synchronous operation that loads the data is actually running all the time. And if we change the orientation, the result will be available at all times. For example, when loader finishes its work, when the orientation changes, we'll have access to its result. We'll say more about loaders in the next module. We can require the activity that we start from our present activity to return a result. This is done with the method onActivityResult. It captures the call setResult to an activity which is above our present activity on the stack. It's often used in applications using the camera, where we start an activity based on the appropriate action to take the photo, and then in the onActivityResult, we get information specific to a given activity. In this way, we can, for example, capture a thumbnail of a photo or locations of files on our disk. To obtain result, we must start the activity with a special method, startActivityForResult, in which we give our request code. It's quite important because afterwards in the onActivityResult, request code is used once again to find out which activity returned the view. It often happens that we start a couple of activities for their results, and then read their results in onActivityResult. To return a result from the child activity, we use the method setResult. Optionally, we can also pass to setResult an intent with all data such as serialization or some ID. That's how it's usually done. We can also pass here a simple integer that will reflect our status code returned from the given activity. After the finish, our method onActivityResult in ActivityParent is executed. So far, we have shown how to start an activity explicitly, stating the identifier in its class. We can also start an activity without stating a specific class and intent. The slide below shows a standard entry in the manifest for our conference application. We have here News Details activity. We also see the declared intent filter in which we have action and category. Android Action is declared as PL Educativo Action, Show Me. We have also defined the default category, which is required in this case to start our application on the basis of the action. If we do not want to start our application by the action, or do not want to do that by an implicit intent, category will not be necessary. On the slide below, we see how to start an activity. If our action will point to the PL Educativo Action Show Me, the system will find our activity registered in the manifest and start it. When the system cannot find activity that matches the action, because, for example, the action stated by us is not defined for any activity in the manifest, we'll get an activity not found exception. This is a runtime exception, which means that our application will return an error. However, this solution is very often used. For example, in starting system activities, such as the camera mentioned earlier. Implicit intents may also have such arguments as scheme or MIME type. However, they are associated with the content provider, and we will discuss them in more detail when discussing this component. We can also pass the activity flag to the intent. We can do this by using the method addFlags, or with setFlags by separating flags with a bitwise operator. I do not recommend the bitwise operator because we use a language of a higher level than C, and such solutions are usually not transparent in terms of clarity of the code. Therefore, the intent offers a method addFlags by which we can individually add each flag. There are a few that we'll discuss in more detail in the practical part. These are such flags as flagActivityClearTask that can clear the so-called task, the context to which our application runs. It can operate, for instance, in two tasks, because it was once started from the Twitter application after clicking on the email, and started again from our launcher by clicking on the Gmail icon. flagActivityClearTop clears the activity stack up to the activity that we currently wish to call. If there is, for instance, a home screen activity, and we're currently 3 levels from it, and we want it back, we do not really need to return some results and then finish each activity until we get to the one on the top. We can just start our activity with this flag and then return to this state. There's also a flag ActivityNewTask, which is associated with tasks mentioned earlier. New task flag is required if we want an instance to start activity from the service or broadcast receiver, which is actually a different context than the activity. It's the end of the module on activities and intents. But this will not be the end of learning about activities, the foundation of our applications. We'll show various tricks also in the practical part, so I encourage you to look at it. Thank you.